Welcome back, everybody. Today we're doing a deep dive into something truly mind-boggling.
Mind-boggling is right.
Yeah, the birth of planets.
Yeah.
You might think we have that all figured out.
Right.
But a recent discovery has really thrown a wrench into everything.
Into everything we thought we knew.
It all started with this article titled, "A Cosmic Surprise, Young Exoplanet Breaks Formation Rules."
And believe me, the surprise is a big one.
It is a big one. So before we get into the rule breaking,
Okay.
let's recap what we thought we knew about how planets form.
Right.
Imagine a giant swirling cloud of gas and dust.
Okay.
Astronomers call this a natal disk,
Right.
kind of like a planet's nursery.
Yeah.
And for years, the prevailing theory was that planets form from this disk, slowly gathering material like a snowball rolling downhill over millions of years.
That was the textbook explanation,
Yeah.
yes. And it made sense. You'd expect a planet to be made of basically the same stuff as the disk it came from.
Right, just like children often resemble their parents.
Exactly.
But here's where things get wild.
Okay.
PDS 70b doesn't match its natal disk at all.
It really doesn't.
It's like finding a brown-eyed baby in a family of blue-eyed folks.
It's a good way to put it. And what makes this discovery even more fascinating
Yeah.
is that we can actually observe this planet forming
What?
in real time.
Hold on, we can actually see a planet being born.
We can. It's incredible.
That's incredible.
It is. The PDS 70 system, where this exoplanet lives, is very young.
Okay.
The planets, PDS 70b and its sibling, PDS 70c, still have their natal disk swirling around them.
Oh,
This is a rare opportunity because it allows us to directly compare the planet's composition to that of its disk, something that's almost impossible to do in older systems where the disk has long since dissipated.
so how did scientists figure out that PDS 70b is so different from its disk? They didn't exactly send a probe out there to grab a sample, right?
No, of course not.
Okay.
They used a technique called spectroscopy, which essentially analyzes the light coming from the planet.
Gotcha.
Think of it like taking a rainbow and examining it very, very carefully.
Okay.
Each element has a unique fingerprint
Uh-huh.
in the way it emits or absorbs light. So by analyzing the light from PDS 70b, scientists can figure out what it's made of.
That's some serious detective work. But hold on, isn't it tricky to isolate the light from a planet when it's right next to a giant blazing star?
Absolutely. It's incredibly challenging. But thanks to advancements in technology, astronomers have developed instruments sensitive enough to tease apart the faint light of a planet from the overwhelming glare of its host star.
Okay, so back to the big surprise. What exactly did they find when they looked at PDS 70b's light?
Well, they focused on the ratio of carbon to oxygen in the planet's atmosphere.
Okay.
And what they found was shocking.
Oh.
The ratio was significantly lower in PDS 70b than in its natal disk. This completely contradicts the traditional model of planet formation.
So if the planet isn't inheriting its composition directly from the disk, where is it getting all its stuff?
Right.
This is where it starts to feel like a cosmic mystery. Right?
Exactly. And that's why scientists are so excited. They've come up with two potential explanations, both of which challenge our understanding of how planets are born.
Okay.
The first possibility is that planet formation might have begun before the disk became enriched with carbon.
So it's like PDS 70b grabbed its building blocks early before the recipe changed.
That's one way to put it, yeah.
Okay, so what's the other possibility?
This one is even more intriguing. It suggests that planets might grow by absorbing more than just gas. Solids like ice and dust could play a much bigger role than we previously thought.
Hold on, I'm a bit confused.
Okay.
How can a planet be selectively feasting on solids?
Right.
Wouldn't it just suck in everything around it like a giant vacuum cleaner?
That's a great question. And it gets to the heart of what makes this discovery so exciting. It suggests that planet formation might be a much more dynamic process than we imagined. Instead of just passively gathering gas, perhaps planets are actively pulling in solid materials from their disks.
Okay, now that's starting to make sense.
Okay.
But how could these solids explain the strange carbon to oxygen ratio we're seeing in PDS 70b?
Well, imagine these solid particles, perhaps chunks of ice or dust rich in oxygen, being drawn into the planet's atmosphere by gravity. As they heat up, they release their elements, potentially changing the overall composition of the planet. It's like adding a secret ingredient to a recipe that completely changes the flavor.
So PDS 70b is like a picky eater, choosing specific ingredients from its cosmic buffet. That's a wild thought. But what about the carbon? Where's that going?
That's the million-dollar question. And it's why scientists are eager to study PDS 70c, the other planet in the system.
Right.
By comparing the compositions of both planets, we might get a clearer picture of what's going on.
It's like having two siblings with very different eating habits.
Yes.
One who loves vegetables and one who only wants dessert.
Exactly.
By studying both, we can learn something about their overall diet, right?
Exactly. And that's why the PDS 70 system is so valuable. It's a rare laboratory where we can observe planet formation in action and test our theories.
So what happens next in this cosmic detective story? We've got the clues, but how do we solve the mystery?
Well, we need more data.
Of course, yeah.
The next step is to study PDS 70c and search for other similar systems.
So the hunt is on for more planets breaking the rules.
It is.
This is getting really interesting.
It is, and the more data we gather, the closer we'll get to understanding the complex dance of gas and solids that leads to the birth of planets.
You know, this reminds me of that time I tried to bake a cake without following the recipe.
Oh, tell me about it. What happened?
It was a disaster. The cake was flat, dense, and tasted nothing like it should have.
Oh, no.
It turns out those seemingly insignificant ingredients,
Right.
the ones I thought I could skip,
Were actually crucial. Just like with planets, it seems.
precisely. It's the interplay of all the ingredients, the precise balance of elements that ultimately determines what kind of planet you end up with. And PDS 70b is showing us that there might be many more ingredients in that cosmic recipe than we ever imagined.
Well, that's definitely food for thought.
Yeah.
But before we dive into the implications of this discovery, let's take a quick break. When we come back, we'll explore what this all means for our understanding of planet formation and the incredible diversity of worlds we see across the universe. Don't go anywhere. Welcome back. Before the break, we were talking about how this young exoplanet called PDS 70b is shaking up our understanding of planet formation.
Totally.
We left off on this cliffhanger. How does a planet end up with different ingredients than the disk it formed from?
Yeah, it's a real head scratcher.
Yeah.
And it's led scientists to propose some pretty wild ideas.
Exactly. We were just discussing those two potential explanations.
Right.
Either PDS 70b formed super early, before its disk had all its carbon.
Or it's actively gobbling up solid bits like a cosmic vacuum cleaner.
Right. And, those solid bits, ice, dust, maybe even tiny pebbles, they might be more important than we thought. Not just for PDS 70b, but for planet formation in general.
Okay, so let's unpack that a little.
Okay.
You're saying that our whole picture of planets slowly accumulating gas over millions of years might be incomplete.
Yeah, it might be more like a construction project, where you need different materials at different stages. Early on, those solid bits could act like seeds, attracting more gas and helping the planet grow faster.
So it's not just a smooth, gradual process.
No.
There could be these bursts of growth as the planet gobbles up solids.
Precisely.
Yeah.
And those solids bring their own ingredients to the mix, literally changing the planet's chemical makeup.
So that explains why PDS 70b might have a different carbon-to-oxygen ratio than its disk.
It could.
It's been snacking on oxygen-rich solids.
That's one possibility. And if it turns out to be true, it could have huge implications for how we understand the incredible diversity of planets out there.
Oh, you mean all those weird and wonderful exoplanets we keep discovering? Hot Jupiters, super Earths, mini Neptunes, planets that make our own solar system look pretty boring by comparison.
Exactly. What if those different planet types arise not just from where they form in a disk,
Yeah.
but also from the specific solids they managed to grab early on?
Hold on, I'm trying to wrap my head around this.
Okay.
So you're saying that the recipe for a gas giant might include a lot of icy chunks, while a rocky planet might feast on more metallic dust.
That's the general idea. Of course, there are likely many other factors at play, like the overall mass of the star and the disk's temperature. But the role of solids in planet formation is definitely moving into the spotlight, thanks to discoveries like PDS 70b.
And this is where PDS 70c, the other planet in the system, becomes really interesting, right?
Absolutely. Yes.
It's like having a control group in a science experiment.
Absolutely. By comparing the compositions of PDS 70b and 70c, we might be able to see if they've been selectively feasting on different solids. It's like analyzing their leftovers to see what they ate.
That's a great analogy. It's like one sibling who loves their veggies
Right.
and another who's all about the dessert. Their leftovers would tell you a lot about their individual preferences.
And who knows, maybe PDS-70C will throw us another curveball, something completely unexpected that challenges our assumptions even further.
Well, that's the beauty of science, isn't it? We're constantly learning, evolving our understanding, and getting closer to the truth, even if it means questioning everything we thought we knew.
Exactly. And this discovery with PDS-70B has opened up so many new questions. For example, could those solid chunks also carry the building blocks of life?
Whoa, now that's a thought-provoking question.
Yeah.
You're suggesting that the seeds of life could be delivered to planets on those icy or dusty bits?
It's possible.
It's like a cosmic delivery service for the ingredients of life.
It's a fascinating possibility, and one that astrobiologists are starting to explore more seriously. If true, it would have profound implications for the search for life beyond Earth.
So it's not just about what kind of planet forms,
Right.
but also what potential it might hold for life. Suddenly, those boring old solids seem a lot more exciting.
Absolutely. And this is why discoveries like PDS-70b are so groundbreaking. They not only challenge our understanding of the universe, but also spark our imaginations and fuel our curiosity about the mysteries yet to be solved.
It's a reminder that there's still so much we don't know about the cosmos. But with every new observation, with every piece of data we gather, we inched closer to understanding our place in the grand scheme of things.
Precisely. And speaking of gathering data, there's a whole new generation of telescopes coming online
Right.
that'll allow us to study exoplanets in even greater detail. Who knows what surprises they might reveal?
Well, that's a perfect segue into our final thought for today.
What's that?
Well, we've learned that the seemingly simple story of planet formation is actually much more complex and fascinating than we ever imagined. And with new discoveries happening all the time, our understanding is constantly evolving. So we want you, dear listener, to consider this.
Yes. What should our listener be thinking about?
What other assumptions might we be holding on to about planets, about the universe, about anything really that could be challenged in the future? What amazing discoveries are waiting just around the corner, ready to blow our minds and rewrite the textbooks once again? It's truly amazing to think about, isn't it? This one exoplanet, PDS-70b, it's really like opened up this whole new chapter in our understanding of how planets are born.
Yeah, it's a perfect example of how science works. Like one discovery can completely change our perspective and send us down this whole new path of inquiry.
And sometimes those paths lead to even more intriguing questions.
Right.
Remember how we were talking about the diversity of exoplanets out there?
Yeah.
Gas giants, ice giants, rocky worlds, all with their own unique characteristics.
It's like a cosmic zoo out there.
Yeah.
Each one more fascinating than the last.
And for a long time, we thought the key to that diversity was simply location, location, location.
Right.
You know, planets that form closer to their star end up as hot, rocky worlds, while those further out become icy giants.
That was the prevailing thought, yeah. But PDS-70b's suggesting that it might not be so straightforward.
Right.
Maybe the composition of those early building blocks, those solids we talked about, plays a crucial role in shaping a planet's destiny.
It's like having a box of Legos
Okay.
with different colors and sizes. You can build a spaceship or a castle,
Right.
all depending on the pieces you choose.
That's a great analogy. And if it turns out to be true, it means we need to reevaluate our entire understanding of planet formation. It's not just about gas accretion anymore. It's about this intricate dance between gas and solids, each contributing to the final product.
So PDS-70b is like a cosmic Rosetta Stone,
Yeah.
unlocking this new language of planet formation.
Like
And that language is telling us that the possibilities are far more vast than we ever imagined.
totally. And that brings us back to your final thought.
Right. What other assumptions might we be holding on to that could be shattered by the next big discovery? What other mysteries are lurking out there, just waiting to be unraveled?
It's an exciting time to be an astronomer, that's for sure. And it's a reminder that we should never stop questioning, never stop exploring, and always be open to the possibility that the universe has a few more surprises up its sleeve.
Well said. The cosmos is a vast and wondrous place, full of secrets waiting to be revealed. And who knows, maybe one of you listening out there will be the one to make the next groundbreaking discovery. So keep looking up, keep asking questions, and never lose your sense of wonder. Until next time, happy exploring.